Welcome to today's daily video lesson. The topic is systems of equations. As with all daily video lessons, feel free to pause the video to attempt the questions before seeing the solution. In this system, we want to find the value of y. When the system gives you one of the values, simply use it and substitute it into the other equation. Thus we have 3 times x, which is 2, plus y equals 29. This is 6 plus y equals 29, and so the value of y is 23. In this case, we want to find the value of y. The second equation isn't explicitly giving the value of x, but it's very close. There are 2 valid ways to solve this. The first is to simply note that x is 5 halves, and using this value in the other equation, x, which is 5 halves, plus y is equal to 5. This tells you that y is 5 halves. If you are more comfortable with the method of elimination, multiplying the first equation by 2 yields 2x plus 2y equals 10. We do this because we have 2x in the second equation, and we want to eliminate the x's. This equals 5. When we subtract these equations, the 2x's go away, and we're left with 2y is equal to 5, which leads to the same conclusion. In this case, we want to find the value of x. Notice that they have given plus y and plus y. Subtracting these equations will get rid of the y's and leave us with only x's. 4x minus 8x is minus 4x. The y's are eliminated, and 4 minus 5 is minus 1. Thus, x is equal to 1/4. In this system, a and c are constant. We want to find an infinite number of solutions. An infinite number of solutions implies that the lines are parallel. And parallel lines have the same slope. We see that the slope of the first line can be obtained first by clearing the fractions to make it easier. We can do this by multiplying through by 6. This gives us 3x plus 2y equals 1. Subtracting 3x from both sides yields minus 3x on the right plus 1, and division by 2 yields y is equal to minus 3 halves x plus 1/2. Thus, the desired slope is minus 3 halves. For the second equation, we have ax plus y equals 6, and rearranging for slope-intercept form yields y equals minus ax plus 6. We see the slope of the second line is minus a. Since these lines must be parallel, and therefore have the same slope, minus a has to be minus 3 halves, and so a is 3 halves. In this particular question, it's a little bit different. Instead, we want to find a constant such that it cannot be that number. We want exactly 2 solutions. We first rewrite this first equation to be y is equal to 1 minus kx. This allows us to only look at the x's. We can say that 1 minus kx is then equal to minus x squared plus k. And rewriting this yields x squared minus kx plus 1 minus k. We want the discriminant to be positive in order for there to be exactly 2 solutions x. The discriminant is b squared minus 4ac, where b is minus k, c is 1 minus k, and a is simply 1 because we don't have a different coefficient in front of x squared. Thus, b squared minus 4ac is k squared minus 4ac c. This simplifies to be k squared plus 4k minus 4. Again, in order to have two solutions, we need the discriminant to be positive. We see that the discriminant will be positive if k is 3, 2, or 1. But the discriminant will not be positive when k is equal to 0, because 0 squared plus 4 times 0 minus 4 is negative.